Sup, everybody? It's Ginger Jesus. Yes, I'm still alive. And a touch sick. I got my tea, though. Okay. Let's get to it. Alright. Can we see this? Here we go. Purpose today, the purpose of this video, keep it short and sweet, is to introduce or reintroduce you to basic trigonometric functions. Trigonometric is a really fancy word for right triangle stuff. We call it trig. Okay? Your goal is to be given a point on the unit circle, we'll talk about that, and be able to identify the sine, cosine, and tangent of the angle that's related to it. Okay? In other words, you see a question that looks like this, and you'll be able to answer it. Okay, you want to pause that and look at it for a second, you can, otherwise I'm going to go on. Okay, so that's the purpose. Alright, first up, some notes. This is the unit circle. Okay? It's a circle that has radius 1 unit, hence why we call it a unit. It's normally plotted on our quadrants of the graph. Notice I got them 1, 2, 3, and 4. Goes counterclockwise. Okay, today we're talking about the relationship between this point, which I've called xy, and the angle that's going to make it. Okay, so I'm going to zoom in just a little bit so we get a better picture of this. Okay, so looking a little bit larger. Here we go. Notice, got my 4 quadrants. If you're recapping from last week, notice each of these quadrants is a right angle, so it's 0 to 90, to 180, 270, back up to 360, and so on. Okay. Now, we're focusing today on the relationship between this point and the angle that's generated it. Okay, and again, it's going counterclockwise, positive direction. It'd be going clockwise if it was negative. All right. So in order to flesh out this relationship, the goal is to use SOHCAHTOA. But in order to use SOHCAHTOA, what do I need? I need a right triangle. So let's make a triangle. How do you do it? Here's how. So hopefully you're keeping up with this, and as I draw on and add on to this diagram, go ahead and add that to your notes too, or pause it and bookmark this part of the video. All right, so here we go. I've done this. I've drawn the height of my right triangle right here, coming straight down from the point to the x-axis, going over this way as well. So I now have a right angle, a right triangle. If you'll notice the height, how far off this x-axis it is, actually is the same as our y-coordinate. So if y was something, this is the same value. Likewise, the width of this triangle is the same as x. Okay, radius is still 1. Now, we're talking about the angle relationship. That's SOHCAHTOA. So if you want to go ahead and pause it and see if you can do this on your own, go ahead and label it with O, H, and A. That's opposite, hypotenuse, and adjacent sides. I've already done it. So here we go. Hopefully yours looks something like this. Notice, here's my angle. Okay, so opposite, meaning the other side of the triangle. So if T is all the way over here, the other side of the triangle is over here. So this is my opposite side. It lines up with Y. Okay? Adjacent, remember you're always touching. Okay, so that's our X side. And our hypotenuse is nicely just 1 because it's a unit circle. The whole radius is just 1. Okay? If you want, the goal of this is to go ahead and figure out what the relationship of sine, cosine, and tangent of t are. If you want to pause it and do it on your own, see if you can figure it out, go ahead and do that. Otherwise, I'm going to go ahead and reveal it. Well, sip of tea first. Okay, you may have already got it. First up, let's talk about sine. Remember, sine is opposite over hypotenuse. So sine of t is going to be y over 1, which again, you never have to say over 1. We can just say y. So to paraphrase a little bit, there we go. Sine of t is nicely y. Okay? You can probably go ahead and guess what cosine is too, but for the sake of it, I'll go ahead and do it. Cosine of t is your adjacent adjacent over hypotenuse, that's your x over 1, which again, don't say over 1, it's just x. Okay? Now, tangent's the slightly stranger one, okay, so we'll go ahead and add that to our notes anyway, but tangent of t is the opposite over adjacent, or y over x. And there's not really a simplified way of saying it, but something you should be aware of, and let's go ahead and add this to our notes too, is that you can also, remember we just said that y is sine, x is cosine, so tangent can also be written as sine over cosine. We won't use that a ton in this class, but it's handy to know if you're going to go study pre-cal next year, or if you want to go study engineering at any point. They'll use that a lot. Okay, so why do we care? Let's recap real quick before we go back to that question. Remember, sine is y, cosine of t is x. So let's go back to this question now. Remember, this was our question. The point P of x, y, on the unit circle that corresponds to a excuse me, that corresponds to a real number t is given as this. Negative root 33 over 7, comma, 4 over 7. And it's asking us to find cosine t. Well, remember, every ordered pair has an x component and a y component, okay? So x goes first, then y. So you can go ahead and see that x is going to be the negative root 33 over 7. Y would be the 4 over 7. And remember what we just said. Cosine of t is equal to what? X. So nicely enough, cosine is just negative, cosine of t is just negative 33 over 7. Root 33 over 7. I'm a little sick, bear with me. I have it written down correctly right here. And if they had asked, and they don't, but if you did need to know, sine would be the y coordinate, which would be the 4 over 7. Cool. If you feel good about this question, then you are now ready to handle the assignment that's called cosine, sine, ordered pairs, comma, quadrants, comma, etc. All right. Good luck, y'all.